What an interesting moment, what a lovely moment we have here. Today we will be looking at ordinary differential equation from a perspective of linear equations. Linear equations we have treated by direct integration. We have treated separable variables. We have treated homogeneous. We are getting to where? We are getting to the linear equation. We are getting to the linear equation. All right, interesting. Now, in the linear equation, one thing that is very, very important is the use of integrating factor. The use of integrating factor. So, if I ask that, consider the equation dy dx plus 5y is equal to exponential to the power of 2x. This is clearly an equation on the first order, but different from those we have dealt with so far. In fact, none of our previous method could be used to solve this one. So we have to find a further method to attack. And so in this case, we begin to multiply both sides by e to the power of 2x. Okay, the use of integrating factor is very important, but you must be able to use it. We only use, so note that, let's write it there. Note that we use integrating factors. We use integrating factors mostly when you have a linear equation. When you have a linear equation. You use integrating factor when mostly you have a linear equation. All right, if that is the case, let us get straight down into the business. All right, so example 1. Example 1, we want to solve this particular question. It's a photo question. It says solve, see that? Solve the y over the x minus y is equal to x. This is very interesting. This is very interesting. Solve. Now, this is a photo pass question. Photo pass question 2019 ODE, right? It says solve the y over the x minus y is equal to x. So the first thing we do, our first step is to compare the equation. Compare the equation with, you see, or to, you compare the equation to the y over the x plus py is equal to q. Yes, you do a comparison. And so if you compare this, now let's compare this with the y over the x minus y is equal to q. Let's compare it. It means that this goes for this goes for this, and this goes for this. Did you see that? So it means that py is equal to negative y. It means that p is equal to minus 1. Did you see that? And then when we have q is equal to q, so there's no need for that. Q is equal to x, rather, sorry, is equal to x. Sorry, let's change this. Q is equal to x. So as we continue, we now discover that the integrating, so step 2, second step, is to discover the integrating factor. See that? See that? You have to discover the integrating factor. And so when you want to discover the integrating factor, the formula, using the formula, discover the integrating factor using the formula e exponential to the power of integral of p dx. See that? You have to discover the integrating factor using that formula. Is that okay? Now, because you understand that p is negative 1, as you have seen it here, p is negative 1. So let's do that. It means that the integral of p dx is equal to negative x, because you are saying integral of minus 1 dx, which is what? Negative x. Is that clear? All right. So the integral of p dx is negative x. It means that this means that the integrating factor, your integrating factor if. So for the sake of this video, I will be giving a short form of the name integrating factor. So we call our integrating factor if. Our integrating factor in this case will be exponential of negative x. Exponential of negative x. It's as simple as that. So step 1 is to compare the equation. Whenever you have seen a function, you compare it to the equation given to you. You compare this particular equation to the equation given to you, and then you derive your p and your q's, and then step 2 will be that what you use the integrating factor. You discover the integrating factor by using the formula. Is that okay? All right. Now, what is the next thing to do? Now, the next thing to do, which is step 3. Let's look at step 3 together. Step 3. That's third step. The third step, or the next thing to do, is to multiply. We multiply both sides. See that? We multiply both sides by the integrating factor. We multiply both sides by the integrating factor. And what is the integrating factor in this case? The integrating factor is e to the power of minus x. So when you multiply both sides by the integrating factor, we're going to have e to the power of minus x, the y over dx, minus y, e to the power of minus x is equal to x e to the power of minus x. Should I explain? So let's assume that this is your equation. Right? So if you want to multiply through, you see that the equation is this, don't forget, the y dx minus e to the power of minus x minus y, sorry. The equation is this, minus y is equal to x. And so when I say multiply by the integrating factor, it means do this. So when you multiply this, you have e to the power of minus x, the y over the x, minus, you multiply again by this, e to the power of minus x, y is equal to x e to the power of minus x. You are multiplying out. Is that not? Just like opening brackets. Is that okay? All right. So we are multiplying both sides by the integrating factor, e to the power of minus x. And so if you do that, this is what you are going to be having. Is that okay? Now, if this is the case, then the next thing for us to do is to then find how to differentiate it, or how to integrate it rather. So we can then say that d over dx of e minus x y is equal to x e to the power of minus x, which means that y e to the power of minus x is equal to the integral of x e to the power of minus x dx. Yes, of course. Do you get me? So when you have multiplied by the integrating factor, then you try to do what? You try to make sure that the right hand side integral can now be determined by the integrating factor itself. You see that? The right hand side integral can now be determined by the, so it's telling us that if you have a function and you have multiplied it by the integrating factor, then you can say d over dx of this guy in the middle is equal to this. Is that okay? Is that okay? So that is what we are saying. That is what we are saying. Is that clear now? With respect to x, don't forget. With respect to x, don't forget. All right. So if you differentiate with respect to x here, that's what you're going to have. We have y e to the power of minus x. With respect to x, if there's a 1 here coming down, right? 1 here coming down. So that is it. Is that okay? So there is no need for us to panic. So if we have d over dx of d to be equal to this, then y e to the power of minus x is equal to the integral of x e to the power of minus x dx. All right. So this means that y e to the power of minus x is equal to x into the bracket of minus e minus x plus the integral of e to the power of minus x dx. Of course, yes. So what it means is that we have this to be equal to negative x e to the power of minus x minus e to the power of minus x plus c. Did you see that? Just integration basic integration. Now if you don't understand integration, like I said earlier, you'll be having problems with ordinary differential equations. If your knowledge of integration is not strong, you will be having problems. That is why we are going to do a series called integration. We will do a series very soon called integration. So y e to the power of minus x is equal to x multiplied by e to the power of minus x plus integral of e to the power of minus x dx. Is that okay? So it means that y e to the power of minus x is equal to negative x e to the power of minus x minus e to the power of minus x plus c. So let's divide both sides by this. Let's divide all by this. So this. So we have y is equal to, right? We have y is equal to minus x minus 1 plus ce to the power of x. Sorry, to the power of x. Because when this one goes up, the negative becomes a positive. So this is likened to you saying y is equal to ce to the power of x minus 1. Did you see that? So this is a method that we use when you discover that your question is in a linear form, in a linear equation form. All right, let's take another example for clarity. Is that okay? Let's take another example for clarity. But before that, let's do something interesting. Consider the y over the x plus p of y is equal to q. You see, where p, see, you must take this down quickly, where p and q are functions of x, it means that, see that the integrating factor if is equal to exponential to the power of integral of p dx, right? So it means that the y over the x, right, multiplied by e to the power of negative p dx plus py multiplied by e to the power of negative p dx, e to the power of integral of is equal to q e to the power of integral of p dx. This is the point where we multiply through by the integrating factor, right? This is the point where we multiply through by the integrating factor. Now, once you do this, you will discover, that's right, you will discover that the left hand side is the derivative of this y to the power of negative p dx. This. Yes. You discover that, yes, that is it. That's what we are saying. We discover that the left hand side is the derivative of y to the power. So when you do that, then you now integrate both sides with respect to x. Then the next step is to do what? Integrate both sides. Integrate both sides with respect to x. Integrate both sides with respect to x. That is it. Do you understand me now? So the results begin to look far more complicated than it already is. So if we indicate the integrating factor, our result, if we integrate, if we indicate, let me put it that way. If we indicate, not integrate, if we indicate the integrating factor, then this means that y integrating factor is equal to q dot integrating factor dx. Yes. Do you understand me now? So that is it. It's very interesting. So let us do something. Another example. Let's look at another example quickly, shall we? Let's look at another interesting example, shall we? All right, example 2. Well, these are photo pass questions. Anyway, this is photo pass questions 2018, number 5. All right, it says x, right? The y over the x plus y is equal to x to the power of 3. Interesting. So what do? You can't compare this to the y over the x plus p. You can't compare it to the regular equation that you have always compared it to. Where's the regular equation? The regular equation says the y over the x plus py is equal to q. You can't compare that. The y over the x plus py is equal to q. You can't compare that just like that because of this man here. Do you understand? So what do we do? We said divide both sides by x. See that? Divide both sides by x. So it means that you are going to be having x, the y over the x, divided by x, plus y divided by x is equal to x cubed divided by x. So this can cancel this. This can cancel one of these. So we have the y over the x, right? Plus 1 over x y is equal to x squared. Thank you. Did you see that? Now it is comparable. Now compare. Step 1 now. Compare the equation given. Compare the equation given to you. With, you see that? With the y over the x plus px plus py, is equal to qx. Did you see that? So if you compare that, you now discover that the y over the x plus 1 over x y is equal to x squared. We are comparing this with the y over the x plus py is equal to qx. We're comparing. So this has cancelled this. So it means that 1 over x is equal to p. It also means that x squared is equal to q. Did you see that? After comparison. So your next step, which is your step 2, your next step is to derive the integrating factor. Thank you. To derive the integrating factor. And I said I'll call it if. Is that not? Yeah. We call it if. So the integrating factor is what? The integrating factor is exponential Let me write it out. IF is equal to the exponential of the integral of P dx. The exponential of the integral of P dx. And so it means that first of all, the integral of P dx is telling you the integral of 1 over x dx. Yes, because P, as you derive, this was your P. Your P was 1 over x. So if you integrate 1 over x, you're going to have an ln x. Is that not? Yeah, you're going to do that. You're going to have an ln x. So it means that your integrating factor is equal to the integral exponential to the power of ln x. Meanwhile, these two cancels out. You see, exponential and ln, they cancel each other out. So this can be like into x. Yes. So notice that step 3. Let me make it easier. Notice that y integrating factor, y multiplied by integrating factor is equal to the integral of q multiplied by the integrating factor multiplied by dx. Let me explain. Let us explain this. If I take from here, let's go back to this part where I solved this question. This. This. So y multiplied by the integrating factor is equal to the integral of q, is a law, multiplied by integrating factor multiplied by dx. Let me explain. If you look at this particular example from here, what was our integrating factor? If you can remember, our integrating factor is this e to the power of minus x, right? Now let's multiply that by y. That's y e to the power of minus x, right? Because the law I want to use now is, the law says y multiplied by if integrating factor is equal to integral of q multiplied by if integrating factor multiplied by dx. This is a law. This is a law. Is that clear? So y multiplied by exponential to the power of minus x, which is the integrating factor, is equal to the integral of what is q. What is q? Remember from our question, our q was x. Look at it. Our q was x. So let's do that. It's equal to integral of q x multiplied by the integrating factor e to the power of minus x multiplied by dx. Is that not? Of course it is. Of course it is. So y e to the power of minus x is equal to the integral of x e to the power of minus x dx. This particular ingredient here is what was written here. Is what was written here. Do you understand me now? So it means that this is equal to this. Do you understand? Of course. Of course. So back to what I was saying, the easier method or the easier way to do that is to just know this law, that y multiplied by if is equal to the integral of x multiplied by if dx. All right, so it means that, let's just go straight to our point. Y multiplied by, what is the integrating factor? Don't forget, the integrating factor here is x. Yx is equal to the integral of, what is your q? Your q in this question is x squared. So x squared, right, multiplied by, what is your if? Your if is x. Integrating factor is x. Is that not? Multiplied by dx. Is that not? All right. All right. So we have yx is equal to the integral of x to the power of 3 dx. Of course. Of course. So we have yx is equal to, what is the integral of this? This is x raised to the power 3 plus 1 divided by 3 plus 1 plus c. Is that not? So we have yx is equal to x to the power of 4 over 4 plus c. Or you can say xy is equal to x to the power of 4 over 4 plus c. Is that not? So that is the solution to that. That is the solution to that. Now let's do something more interesting, should we? Example what? We are in example 2. Example 3. Let's go to example 3 quickly. Example 3. Example 3. It says solve the y over the x plus y cot x is equal to cos x. Alright, sorry for the intrusion. Back to our question. The y over the x plus y cot x is equal to cos x. So let's compare. Compare with, what are you comparing it with? You're comparing it with the y over the x plus p of y is equal to q. That's what you're comparing it with, right? And so when you compare it, you now discover that p is equal to p is equal to cot x, right? And q is equal to cos x. Did you see that? Very interesting, right? We have compared. So it means that our integrating factor is exponential integral of p dx. Which means we have, what is the integral of p dx in this case? We are saying the integral of cot x dx, right? And the integral of cot x dx is, remember, cot means, the word cot means cos of x divided by the sine of x. That's the word cot. So this is what we are talking about. The integral of cos x divided by sine x, which is ln sine x. Yeah, ln sine x. All right. So it means that integrating factor is equal to the exponential of ln sine x, which is equal to, so this cancels this, which is equal to sine of x. Yes, integrating factor is sine of x. And so when we have the integrating factor is sine of x, it means that y integrating factor is equal to integral of q integrating factor dx, which means that y sine of x is equal to integral of, so we are quoting this law at this point. Y sine x is equal to the integral of, what is q? Q is cos x. Okay, cos x, sine x, cos x, however you want to say it. But we say sine x, cos x dx, right? So y sine x, what is the integral of this? Sine x cos x dx. Our answer is sine squared x over 2 plus c. Anyway, we're going to treat this part in our series called integration, right? We're going to treat that there, integration. So this is what we have here. And so we say that y is equal to sine x sine squared x divided by 2 times 1 over sine x plus c times 1 over sine x. So it's just that we are dividing both sides by sine x. So our y is equal to sine x over 2, because this will cancel one of these, plus c over sine x. Did you see that? That is our answer. Is that okay? So all these are methods we use when we are dealing with linear equations. Is that okay? All right. So let us take the last example for the day. Our last example, let's look at something very interesting. Very interesting. I believe you'll be able to do this yourself. So let's see. This says solve x plus 1, the y over the x plus y is equal to x plus 1 all squared. It says solve this. So when you want to solve this, what do? The first thing I told you can't compare it straightforward. So you are going to divide this by x plus 1, x plus 1, x plus 1, right? So if that's the case, you'll be having the y dx plus 1 over x plus 1 multiplied by y, yes, is equal to x plus 1, because one of these will cancel one of these. Okay, so we have this. Now let's compare. Y over dx plus py is equal to qx. Let's compare. It means our p is 1 over x plus 1 and our q is what would our q be? X plus 1. Yeah, x plus 1. Is that not? So that is it. All right, so is equal to q. Sorry, it's q. Anyway, let's continue that quickly. So in this case, let us find the integrating factor. Figure out or derive the integrating factor. Derive the integrating factor. Integrating factor is IF, which is exponential integral of p dx, which is exponential integral of what is p? 1 over x plus 1 dx. Is that not? Is that not? All right. So this is ln x, right? Integral of this. First of all, the integral of 1 over x plus 1 is ln x plus 1, ln x plus 1. So what I have here is integral of ln x plus 1, right? Yes, ln x plus 1. So this cancels this, and then we are having x plus 1. Did you see that? Did you see that? So we are saying that, recall that if y multiplied by integrating factor is equal to the integral of q multiplied by the integrating factor dx. So y multiplied by, okay, so what is integrating factor? Y multiplied by x plus 1 is equal to integral of, what is q? Q is x plus 1, right? Q is x plus 1. Q is x plus 1. Okay, x plus 1. Integrating factor is also x plus 1 dx. Wow, interesting. So we have y x plus 1 is equal to the integral of x plus 1 all squared dx. Is that all? Okay. So what do we do from here? We say that this becomes we have it as x plus 1 all to the power of 3 over 3, of course, plus c, right? So we can now say that y x plus 1 is equal to x plus 1 all to the power of 3 over 3 plus c. So let's divide both sides by x plus 1. Divide through by x plus 1. It means that your y is equal to x plus 1 all squared divided by 3 plus c over x plus 1. All right, so that will be all for using integrating factor to find the solution to a differential equation. All right, so questions, if you have questions to ask me, you can chat me on WhatsApp 669385. WhatsApp. Is that okay? All right. Thank you so much. We really, really appreciate you.